All right, Liddell, sorry, my recording stopped, so here's take two. Each one of those has the derivative of 3x squared. Okay, now what we're going to start doing is they're going to start giving you this, and they're saying find the find the antiderivative, which basically gets you back to the original function. Okay, but what they'll do is they'll say find the antiderivative of 3x squared. And the antiderivative, really, to get back to the original, all of those are the antiderivative. So every time you take the antiderivative of 3x squared, the general antiderivative is going to be x to the third power plus c. This is the antiderivative. Okay, because when we get back to the original function, we have to put that plus c on the end there because taking the derivative of a constant makes it go away. So when we're going back the other direction, we have to put that there's a constant on the end there. Now, we don't ever know, we won't know what that number is unless they give us more specifications about that number, which we'll talk about later. But x to the third plus c is my antiderivative. Okay? Good? Does that make sense? Okay. Let's go through some of this terminology. The constant c is called the constant of integration. So that's this guy here. He's basically the number that falls off when you take the derivative, but finding the antiderivative going back the other direction, you need to have him included. Okay. The general antiderivative is this whole thing right here. Is to the x to the third plus c. That's the general antiderivative. And a specific solution would be each one of these. Okay, each one of these is a specific solution. Okay. Right? These are specific solutions for the antiderivative of 3x squared. Yeah? Each one of those is technically an antiderivative of 3x squared. This one is the general one because it encompasses all three of them together. It's just adding a constant onto the end. Okay? So, we don't know the rule for finding the antiderivative yet, but if the derivative, so they're saying if the derivative is 2, they're saying y prime is 2, what would the original equation of y have to be in order for the derivative to be 2? Y would have to be, Wynn said, 2x. If I take the derivative of this guy, do I get that guy?
No. Plus c.
And you need to have your plus c on the end there, right? Okay. So 2x plus c, the derivative of that is just 2. Do we agree?
Yes.
Yes? Okay, so you did that one in your head, but when it gets a little bit harder, there is a rule to finding the antiderivative. Are you ready for it?
Yep.
Okay. Here is the rule for finding the antiderivative. It is, we'll just put it off to the side over here. Put a star or a box or something really big around this. Okay, the rule for finding the antiderivative is 1 over n plus 1, x to the n plus 1. Okay, 1 over n plus 1, x to the n plus 1.
Wow, that seems really simple for...
Right, yeah, it's not too bad. Yeah, that's not too bad. 1 over n plus 1, x to the n plus 1. So let's use the thing that I had up at the top here. I'm finding the antiderivative of 3x squared, right? If I'm using that formula to find 3x squared, to find the antiderivative of 3x squared, okay? All right, the 3 is just going to chill out for a minute, okay? The 3 is not going to do anything. So we're going to take him off of the front. Okay, what is n in this case? N is going to be this guy. Okay, and so I do 1 over 2 plus 1, x to the 2 plus 1. Okay, the 3 is just going to chill. If you ever have a number on the front, he's just going to chill out front, right? So 1 over n plus 1, x to the n plus 1. You see that? This is how you do this. Okay, 1 over 2 plus 1, this guy is just 1/3, x to the third power. Do you agree? Got it? 1/3 x to the third power. If I do my 2 plus 1s, okay? But what is 3 times 1/3?
1.
Just 1, which is just x to the third power. What? No. 1/3 of 3 is just 1.
Oh, he's saying that trace
So it's
hockey
1
is the
x to the third power.
Quattro.
Sure. Okay?
So-
Do you see how we get that? It gets easier the more you do it. Okay? X to the third power. Stop. Stop. I'm going to kick you out. X to the third power. Okay? Good? That's how you do the 1 over n plus 1, x to the n plus 1. If there's a number out in front, you just let him chill for a minute. Then do your 1 over n plus 1 and simplify. Okay? All right. This is the notation that they will use. Ready? This is what an indefinite integral looks like. Write this down. indefinite, indefinite.
That's a weird looking S.
Nite. Yeah. It's an integral symbol. This is an indefinite integral. Indefinite integral. Okay? So, using the same stuff that we had before, I'm going to say the integral of, let's say, what do I want to do?
I can't draw
3x squared dx is equal to x to the third plus c. This is the notation that they will use, okay? So they will give you this information and they will say solve it. What that means is take, this guy says, take the antideriv with respect to x. That's what this thing says. It means take the antiderivative of that thing with respect to x. Take the antiderivative
So
of
that
3x squared
dx means
with
nothing.
respect to x. Really, no. Yeah. It's just telling you what your variable is. Okay? Take the antiderivative with respect to x. And this is the answer. Whoop. This guy is my answer.
D.
Okay?
What if it was dy? That makes it way more difficult.
Yes, but if they say dy, then your variables will be y's in there.
Well, what if it's not?
They won't give anything to you that's that hard.
Okay.
No, they won't.
Great.
I thought we were done with this dx.
I know. I know.
If it was like a D.
So it's just a notational thing, okay? So the answer, this is the notation that they will use for finding the antiderivative. You have the integral, which just says find the antiderivative. The dx on the end just means that that's the variable that I'm using, okay? So antiderivative with respect to x of 3x squared, you do the 1 over n plus 1 x to the n plus 1. That's that guy, okay? Let's go to the back side and let's do a bunch of these, okay?
Yes.
Yeah,
Oh my
sure.
Christ.
Okay. All right, ready? Let's look at, these are all just finding the derivative on the left side. Finding the derivative is differentiation formula, right? If I'm taking the derivative, which means d over dx, this means take the derivative, deriv, of c. What's the derivative of a constant?
CX.
They give you the answer. What's the derivative of c?
0.
0, right? Okay. Number 2 says we want to find the derivative of k times x, like 4 times x. What's the derivative of 4 times x?
The constant.
Just that constant that's out in front, right? 4, right? These are all just saying that, okay?
Wait, where do you do the fourth?
I'm just saying like kx is just an example of 4x, okay? So the derivative of that is 4, right? This is saying find the derivative of k times like f of x. So like 3x squared, and they want you to find the derivative of that, right?
No.
The 3 out in front is doing nothing. It's just saying take 3 times the derivative of x squared, which is 2x, which will make this 6x, right? That 3 is just tagged along in the front. Does that make sense? 3 just gets tagged along in the front. Good, good? These are all the rules. Number 4 is saying find the derivative of things that are added together. So like x to the third plus 4x squared. Okay? And when you're taking the derivative of those things, it's just saying find the derivative of the pieces individually. So what will the derivative of that guy be? 3x squared plus 8x. There he is. Okay? 3x squared plus 8x. All right, and then this is just the general rule for derivatives. So x to the 7th power. You would just take the n down in front and subtract 1. Those are all the rules for derivative. We know how to do all those. We know how to do all those, right? Those are just general power rule stuff. You know, if you have numbers out in front, it's not going to do anything. If you have 2 things that you're adding together, like this guy right here, you just do each piece individually, right? Okay, now let's look over at antiderivatives. If I'm taking the antiderivative of 0, which means what would I be taking the derivative of to get 0?
A constant.
It's going to be a constant, right? It's like the reverse, okay? Now, if I have a constant number, like we did on the front side, it said y prime equals 2. What would you be taking the derivative of to get 2? what would you have to take the derivative of to get 2? 2x, but then we need plus c on the end there, right? That's the
Or x
antiderivative.
squared.
Okay? No. 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 Because the derivative of x squared is 2x, right? That's not right. Okay? And so these rules are just basically saying the reverse of that. The thing that you want to really remember is this guy right here. This is the formula that I gave you on the front side. Circle him really big. That's the formula. 1 over n plus 1, x to the n plus 1. And then don't forget plus c on the end. I remember on this test that I gave you, like for chapter 6, like way on down the road, a couple weeks from now when we take a test over chapter 6. At the very top of the test, I put, don't forget plus c. Make sure you have plus c on your answer, right?
So like you need plus C for every single one.
Every single time you take an antiderivative, he needs to have a plus c. Until we get to things called that are definite integrals. And I'll show
How do
you.
you do that?
Definite integrals have numbers that you're going to plug in. So I'll show you the difference. Just wait till we cross that bridge, okay? Definite integrals, okay? So let's look at these guys here. Example 1. You are going to have to rewrite each one of these and then find the antiderivative, okay? So this is saying we want to find the antiderivative of 1 over x to the 3rd power. So basically we're trying to find what you would take the derivative of to get x to the 3rd power, or 1 over x to the 3rd power.
Yeah, this one.
But let's rewrite this thing. So if I want to rewrite him,
X to the negative 3.
this would be x to the negative 3rd power, right? And I'm going to put my integral symbol and I'm going to say dx, okay? So I want to rewrite him as x to the negative 3rd power. We would do that if we were taking the derivative of him, right? Okay? But we want to do the antiderivative, which is the 1 over, whoop,
Is it negative 1/4 x to the
No.
4?
No.
4?
No.
Sure.
Yep. Because what's negative 3 plus 1?
Oh, it's
Yep.
1/2.
Yep. Negative 1/2.
Negative 1/2
Okay.
to the x
So
to
let's
the
do this real quick.
Yeah.
X to the this part right here. So 1 over n plus 1. What's your n in this case? 1 over n plus 1, x to the n plus 1. That's those pieces. What's your n? Negative 3. So I take 1 over negative 3 plus 1. X to the negative 3 plus 1.
You know,
Okay.
that equation makes it way easier.
What?
This thing makes it way easier.
What?
The equation thing.
Yeah.
Yeah.
Mhm.
It's
Mhm.
not some stupid equation.
What do you mean?
A lot of equations that we do are really retarded.
Okay, cool. So this guy, what is 1 over negative 3 plus 1? What is negative 3 plus 1? Negative 2. I'm going to put the negative out in front, so I'm going to make this negative 1/2. X to the
2 negative 2.
negative 2 power, but now I want to make him positive 2
Why?
because I want to fix him.
So just put negative 1 over 2x.
2x squared. I'm going to put the 2 back down in the bottom. And this is my antiderivative
C.
except plus c. Don't forget your plus c's. Okay? All right, so we rewrote him, we took the antiderivative, and then we fixed him back again. You see what we did? Questions about that? If you're like, I don't know, I'm not sure what we just did, I probably couldn't do that by myself, it will get better because the more we do this, the easier it will become. Okay? But did you follow along with what we did? Right? Moving the 2 back, the x squared back down below. Okay? Good. And then we do something like number 2. Are you ready? We're going to be all over the page here because I didn't give you very much room to write each one of these. Sorry. Number 2, how do we want to rewrite him? What can we do to rewrite him and make him better?
X to 1/2.
The square root is 1/2 power, so dx. There we go. Integral x to the 1/2 power dx. Okay? All right, good. Now we're just going to do 1 over n plus 1 x to the n plus 1. Oh, to the n plus 1. Okay? All right, just fill in your formula every single time to look like this. Okay? What is your n in this case?
1/2.
1/2. Okay? So I do 1/2 plus 1 and 1/2 plus 1. Okay? This takes a little bit of thought to do this.
2 over 3 x.
Because it's 3 over 2 to start with. Where's my extra 6 one? Do we have it? Do you want me to stop recording, Liddell?
That's
What?
that's fine.
Keep recording, stop recording.
Am I
Stop.
done?
Stop it?
Yeah.
Okay.